Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve remaining problems of quiz 1 on fluid mechanics of IIT Bombay. So these are the questions. The first question is a plate 0.035 mm distant from a fixed plate moves at 0.6 meter per second and requires a force of 2.5 Newton per unit area to maintain this speed. Determine the fluid viscosity in poise between the plates. So the question is there is a two plates. This one is fixed. This one is moving with velocity 0.6 meter per second. The distance between these two is 0.035 mm. And in between these two plates there is a fluid. And force of F is F by A per unit area 2.5 newtons is applied to maintain constant velocity. So determine the fluid viscosity in poise between the plates. See, when you are trying to apply force 2.5 Newton per unit area, means Newton per meter square, shear force on the plate, it is going with velocity 0.6 meter per second. It is a constant velocity. Means constant velocity means on the plate, the net force should be zero, right? So the net force on the plate should be zero. So here we applied 2.5 Newton per meter square. Because of the fluid particles in contact with the plate, they will try to resist the motion of the plate, right? So they will apply shear stress tau in this direction. So from equilibrium, we get tau shear stress will be equals to 2.5 Newton per meter square, right? So shear stress at the plate, the shear stress at the plate on the fluid is 2.5 Newton per meter square. So we know that generally about the fluid, nothing is mentioned. So we generally assume Newtonian fluid. So for Newtonian fluid, tau is equals to mu into dou u by dou y. So we already know mu is given as, so we need to find out mu. So dou u by dou y, here see the velocity here will be 0 because it is a fixed plate and the velocity here is 0.6. So the variation will be linear from 0 to 0.6 because the distance between the plates is very less. So dou u by dou y can be written as 0.6 divided by 0.035 into 10 power minus 3, right? So that will be is equals to 0.6 into 10 cube divided by 0.035. So this is dou u by dou y. So tau will be is equals to mu into dy. So mu will be is equals to tau divided by dou u by dou y. So shear stress is 2.5 divided by 0.6 into 10 cube into 0.035. So let us calculate the value. 2.5 into 0.035 divided by 0.6. We are getting 0.145833 into 10 power minus 3 pi, right? This is in SI units. But they asked in poise. Poise is CGS unit. So we already know that 1 pi will be is equals to 10 poise. So this will be is equals to mu is equals to 0.145833 into 10 power minus 2 poise. Okay. Let us go to next question. This is the next question over here. The velocity distribution in meter per second near the solid wall at a section in a laminar flow is given by u is equals to phi sine of phi pi y. If the dynamic viscosity of a fluid is 2 poise, the shear stress at y is equals to 0.02 meters each. First, let us discuss about dynamic viscosity and kinematic viscosity. Dynamic viscosity is generally called as viscosity, that is represented by mu. The units are Pascal second, right? So Pascal second means force per unit area into second. So this has Newton's term, means force term, right? Force dimension. That is the reason it is known as dynamic, right? One more is kinematic viscosity. that is given by mu by rho. If you observe the dimensions of this kinematic viscosity, there will be no dynamic terms represented, because if you see Pascals is Newton per meter square, Newton means mass into uh, acceleration, right? So meter square per second, this will be second divided by meter square into rho. Rho means density, density means mass by volume, so mass into mq. So the second gets cancelled. Sorry, this will be meters per second square. So second gets cancelled. This meter square and meter square gets cancelled. We will get meter square per second, right? So in this there will be no term of dynamics, means no term of force. So this is known as kinematic viscosity. So kinematic viscosity is given by dynamic viscosity divided by density, right? So this is about kinematic viscosity and dynamic viscosity. Now let us solve the question. We need to find out shear stress. We already know if nothing is mentioned, we assume Newtonian fluid. So for Newtonian fluid, tau will be is equals to mu into dou u by dou y. And we already know the distribution of shear stress, that is u is equals to 5 pi sine of 5 pi y. So dou u by dou y will be is equals to 25 pi cos of 5 pi y, right? So tau is equals to mu is 0.2 poise. In SI units it will be 0.2 poise. So 0.2 into 25 pi into cos of 5 pi y, right? So this will be is equals to 50 by 10 means 5 pi cos of 5 pi into y is 0.02 meters. So we will get 5 pi cos of 5 by 10. So pi by 10 is in radians, but we need to convert it into degrees, because generally our calculators are in degrees. So this will be 18 degrees, right? So this will be is equals to 5 pi cos of 18 degrees. So that is equals to 5 into 5 into cos of 18 degrees. So from this we get tau is equals to 14.939 pascals. This is the answer for this question. With this, we completed the question paper of quiz 1. Thank you.